There are many electrical distortions that force current and voltage waveforms from their ideal sinusoidal shape. The two most common distortions are harmonics and non-unity power factor. These two distortions are the largest contributors to excessive heat and needless wear and tear in the electrical network and to connected loads. The presence of them also impedes the electrical network efficiency, which results in higher repair and maintenance expenses and more money spent on wasted electricity. The source of harmonics in data centers are from loads operating in the electrical network drawing power in a non-linear way. Power supplies in particular introduce harmonics and add excessive heat into the environment. The sources of poor power factor are typically related to the motors running the HVAC and also from various lighting, transformers, or generators. These distortions are always present in data center electrical environments. There is an enormous amount of information from various industry leaders documenting the additional expenses on repair and maintenance of infrastructure and how they increase power consumption. We will include some of these resources in the post beneath this video. Next, we will look at how subcycle correction dynamically eliminates harmonic distortion and maintains power factor at unity. We have turned the power controller on and off for 30-second increments for several minutes. Now we will speed up that footage to demonstrate the difference between when subcycle correction is turned on and off. First, we will focus on harmonics, then we will focus on power factor. If you are unfamiliar with our dashboard, please see the previous video, Part 2, Demonstration Interface. Bottom left portion of the screen individually graphs the current harmonics on each phase in a real-time bar graph. Each column is made up of 4 bars. The bars show the real-time harmonics on each phase, with the first 3 bars color-coordinated to the phases, and the 4th being an average of the 3. The scale is logarithmic and in real time. We have presented the averages on the chart to the left. You can see that the THD was decreased on all 3 phases, with the L1 experiencing the largest decrease from 117% down to 2%. When the power controller is turned on, the harmonics are maintained near ideal and are perfectly balanced across the phases. Less harmonic distortion on the server rack reduces the heat of the connected power supplies and increases the electrical efficiency. Now we will replay the same on and off footage, but focus on power factor. The average power factor on all 3 phases is increased and maintained near unity. The first phase, with just the lighting, experienced the largest increase from 0.41 to 0.99. With the Vector Q2 turned on, this server rack is operating at optimum efficiency. This video demonstration clearly shows the negative effects of uncorrected power in a single server rack. A typical data center has anywhere from dozens to hundreds of server racks, all introducing similar harmonics and power factor as shown in this video. Combined, these distortions increase expenses on power, repair and maintenance of equipment, and contribute significantly to downtime and power disruptions. The Vector Q2 power controller dynamically corrects electricity and eliminates virtually all distortions with the same effectiveness as demonstrated in this video with power factor and harmonics. This includes voltage sags and swells, frequency deviation, ground or neutral currents, noise and resonance, and others. With the 3DFS solution, correction is not limited to server racks. 3DFS provides the same protection and quality of service for HVAC, lighting, UPS devices, and any other connected load. Data center electrical network and all loads operate at peak efficiency every microsecond, year-round with 3DFS.